Welcome to this explainer. Today, we are going to completely flip the way you approach your Cambridge examinations. We're going to treat your computer science and information technology exam answers like a structural masterpiece. Now, we are zeroing in on a topic that literally trips up thousands of students every single year. I'm talking about data validation. Look, whether you're studying Cambridge syllabus code 0417, 0478, 2210, 9618, or 9626, the principles of checking data accuracy are absolutely foundational. They are the bedrock of your exam paper. I want you to think of your exam answer as a building. You wouldn't just grab an armful of bricks, throw them randomly at an empty plot of land, and hope a beautiful house magically appears, right? Of course not. Yet, believe it or not, that is exactly what most students do when they sit down in the exam hall. The panic sets in, they throw a bunch of memorized facts at the page, and they just pray the examiner finds something worth giving a mark to. Well, we are putting an end to that today. We are going to design your answer like a master architect. We're going to make sure every single paragraph you write is such a structural masterpiece that the examiners literally have no choice but to award you full marks.
Here's our architectural blueprint for today's session. We're kicking things off with the challenge, identifying exactly where the wheels fall off for most candidates. Next, we hit the core principles of checking data accuracy. Then, we go through the transformation to turn a terrible answer into a perfect one. We'll follow that up with an interactive workshop, unlock some examiner insights, and leave you with the final blueprint. Let's get right into it.
Section 1. The challenge.
Let's look at where things go spectacularly wrong.
So, Section 1.4 of the syllabus focuses heavily on checking the accuracy of data. Now, here's the secret. The examiner does not just want to know if you can recite the textbook definition of a range check. They want to know why it's the absolute best choice for a highly specific database scenario compared to, say, a type check. Yet, look at these two super common traps students fall into. Let's look at Alex. Alex has memorized the entire computer science textbook. When a validation question pops up, Alex gets excited and just overloads the page with raw facts. Range checks, format checks, check digits. It's just a massive brain dump of information that completely ignores the actual scenario the examiner provided. There is zero analytical depth. It's all knowledge, no application. Then, on the other hand, we have Sam. Sam actually understands the scenario, but the clock is ticking. Sam panics, rushes the execution, and totally misses the command word requirements. The question explicitly says evaluate, but Sam just describes. Sam completely misses the context and fails to build any causal relationships. Both of these students end up with massive amounts of red pen on their exam papers.
Every year, the principal examiner reports are published, and they show us exactly where these easy marks are lost. And I mean easy marks. We're going to fix this faulty foundation right now. You see, the reports consistently tell us that top-scoring candidates demonstrate evaluative thinking. What does that actually mean? It means they question assumptions, they look at different perspectives, and they justify their decisions with hard, scenario-based evidence. When you just jump straight to an answer and fail to evaluate the quality of the evidence, or when you don't identify the limitations of a validation method, you are just leaving marks sitting on the table. But don't worry, because by the end of our time together today, you are going to possess the exact cognitive framework you need to completely dominate these distinct domains of knowledge, application, and analysis.
Section 2. Core principles, the theoretical foundations of your blueprint.
To build an unshakable answer, you need a rock-solid understanding of systematic analysis and evidence-based reasoning. You cannot look at data validation in a vacuum. It connects to database design, it impacts the user interface, and it's a huge part of system security. Now, there are 6 specific validation methods that you absolutely must master. Think of them as the frontline security guards of a computer system. First, we have the presence check. This is the absolute baseline. It simply ensures a field isn't left totally blank. If you don't type anything in, it stops you. Next is the range check. This ensures numerical data falls within a logical boundary. For example, making sure an age entered isn't a negative number. Then we have the type check, which verifies the actual data material. It's the guard that ensures you aren't trying to type alphabetical letters into a field meant strictly for numbers. After that is the length check. This looks at the character count, which is incredibly crucial for things like standardized phone numbers or passwords. Then we have the format check. This one is all about structural integrity, checking the specific layout of data, like making sure an email address actually has an @ symbol in the middle of it. And finally, we have the check digit. This is the ultimate, heavy-duty inspection tool. It's an extra mathematical value that is calculated directly from the data itself to spot transposition errors, like when you accidentally swap 2 numbers around. It's super common in barcodes.
So, knowing the 6 methods is great, but the real game changer is how you structure this knowledge on the exam paper. Top students, the ones getting the highest grades, structure their answers using the PEEL framework. That's P-E-E-L. Point, evidence, explanation, link. First, you make your point about a specific validation method. Then, you provide evidence directly from the scenario in the exam question. Next, you give an explanation of the causal relationship, meaning how does this method specifically solve the problem at hand? And finally, you link it back to the overarching requirement of the whole system. This framework literally forces you to hit those higher-order assessment objectives. It forces you to be analytical and evaluative rather than just descriptive. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 3. The transformation. Let's see the method mark strategy in action.
All right, let's watch those red pen marks turn into satisfying green check marks. You have to understand that in Cambridge computer science marking schemes, marks are very frequently awarded for the process itself. The examiner wants to see how you arrived at an answer, not just the final conclusion you reached. The standardized sequence you see here is exactly how you secure those critical process marks. Step 1. Identify the key elements from the text or the tables provided in the specific exam question. Don't invent things, use what's there. Step 2. Apply the relevant theoretical principles. This is where you decide which of those 6 validation methods fits the problem best. Step 3. Execute your analysis with super clear working. Listen, if it's a comparative analysis question, you must explicitly identify similarities and differences using comparative connectives. Words like whereas or conversely are magic words to examiners. Step 4. Verify your results by checking the limitations or the assumptions of the method you chose. And finally, Step 5. Present the information following strict conventions. Use proper terminology. Do not just write, "it checks the letters." That gets you nothing. Instead, write, "it applies a format check to ensure alphanumeric structural compliance." Using this practical application shows the examiner that you've developed professional skills, and they reward that heavily.
Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Interactive Workshop. It's time to test your skills under pressure. Data interpretation is an absolutely critical skill for Section 1.4. You have to be able to extract meaning from complex texts and tables, interpret the relationships, and draw solid, evidence-based conclusions entirely on the fly. I want you to imagine you are sitting in the exam hall right now. The clock is ticking down, the invigilator is walking the aisles. You have exactly 60 seconds to scan the provided table and extract the core relationships. You need to look for the connection between the data field, the validation required, and the justification. Remember, we aren't just looking for the what here, we are aggressively hunting for the why. Get ready.
Take a really close look at this data structure. First, we have a user ID that needs both format and length validation. Why? Because the justification tells us it must be exactly 8 characters long and alphanumeric. Then we have an age field requiring a range check. This is to ensure the user is an adult, over 18, but realistically under 100 years old. Finally, look at the email field. It needs both a presence check, because it's a mandatory field that cannot be left blank, and a format check to ensure it actually contains the standard @ symbol and domain structure. Now, if you immediately recognize the specific limitations and assumptions for each of these fields, congratulations, you are thinking exactly like an examiner. You notice the key trend here. A single data field very often requires multiple overlapping validation methods to actually be secure. An email format check is completely useless if the system allows the user to just leave the field blank, right? Hence the absolute need for a presence check alongside it. That's the analytical depth you need.
Let's keep the momentum going with Challenge 2. I'm going to show you a sample paragraph. This was actually written by a student in a real Cambridge exam. Your job is to find the fatal flaw. I want you to review the text and identify exactly where the student failed to evaluate the evidence properly. Keep your eyes peeled for missing causal relationships, poor computer science terminology, or those terrible generic statements that fail to link back to the scenario. Let's see what you spot.
Okay, read this carefully. A check digit ensures the data is correct. The presence check stops errors. Both are good for databases. Wow, this is a classic textbook example of a flawed answer. It confuses cause and effect entirely, and it completely lacks specific comparative connectives to show similarities and differences. Let's break it down. First, a check digit absolutely does not ensure data is correct in the real world. It only ensures the data is valid according to a specific mathematical algorithm. Think about it.
It cannot tell if you entered someone else's perfectly valid barcode by mistake. Validation is about rules, verification is about truth. This student confused the two. Second, saying a presence check stops errors is way too broad. It doesn't stop all errors, it specifically prevents null values from entering the database. And finally, that last sentence. Both are good for databases. That is the most generic, empty sentence you could possibly write. It earns 0 marks. It provides no context, it shows 0 analytical depth, and it completely fails the evaluation assessment objective. Never write a sentence like that.
All right, let's fix that kind of terrible writing right now in Challenge 3. You have 30 seconds to mentally construct or speed write, if you've got a pen handy, one perfect Peel paragraph. Using the comparative analysis framework we talked about, I want you to justify your decision between a length check and a format check for a brand new password field in a banking application. Think about it. Point, evidence, explanation, link. Go. Okay, here's what a top-tier answer looks like. You would state that while a length check ensures the password meets the minimum 12-character security requirement, that's your point and evidence, a format check is simultaneously crucial to mandate the inclusion of special characters and numbers, that's your explanation, thereby collectively preventing brute force dictionary attacks on the banking platform, and that's your link back to the system. Boom! That is exactly how you secure top marks.
Section 5. Examiner Insights. Let's go straight to the source. Let's totally demystify the critical analysis requirements straight from the people who actually mark your papers. Every single year, Cambridge publishes principal examiner reports. Honestly, these documents are absolute gold mines of information. They detail exactly what candidates did well, and more importantly, where they failed miserably across syllabus codes like 0417, 9618, and 9626. Examiners consistently report 3 major recurring pitfalls. Number 1, students constantly confuse cause and effect in validation methods. They somehow think a format check actively changes or fixes the data, rather than understanding it just acts as a strict gatekeeper. Number 2, students forget all about formatting and presentation. If a question explicitly asks for a report format or for specific, clear annotation, and you just write a giant messy block of text, you are going to lose those vital process marks. And number 3, which is frankly the biggest one of all, failing to provide context-specific answers.
I really want to pause and emphasize this point because it is vital to your success. The classic #1 mistake is providing generic answers. Listen to me. If the exam question describes a complex hospital patient database and you simply write down the textbook dictionary definition of a type check without explicitly linking it to checking a patient's blood type field or their admission date, you will drop critical marks. Always link every single point to the given scenario. The principal examiner reports highlight time and time again that candidates who reference cross-topic connections, for instance, directly linking data validation to data integrity and system security within that specific hospital context, are the ones who achieve significantly higher marks. It proves to the examiner that you have genuine analytical depth. Section 6, the final blueprint, your strategy checklist for exam day.
Let's recap the ultimate architectural blueprint. This is the final checklist you need to memorize before you walk into that exam hall. If you master these 3 rules alongside the higher order assessment objectives of evaluating alternatives, your grade will absolutely transform. Rule 1, command word decoding. You have to know what you are being asked to do. Are you being asked to describe, explain, analyze, or evaluate? If the command word is evaluate, you must weigh alternative methods and provide a fully justified recommendation. Rule 2, Peel framework application. Promise yourself right now that you will never write a loose, rambling sentence again. Every single paragraph must have a point, evidence, explanation, and a link back to the specific scenario. Rule 3, time management matrix. You must allocate your time based purely on the marks available. Do not spend 10 precious minutes writing a beautifully detailed description for a tiny 2-mark question, only to end up rushing a massive 10-mark evaluation question at the end of the paper. Build your answers systematically, minute by minute, mark by mark.
The data from our community absolutely does not lie. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. They stop randomly guessing what the examiner wants, and they start delivering structured, evidence-based reasoning every single time. But knowing the blueprint isn't enough. You actually have to put in the work and build the house.
You've got the tools, you understand the blueprint, and now you just need the consistency. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams,
@acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Is it remembering the specific validation types, or is it applying the Peel framework under time pressure? Let me know. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. Keep building those perfect, structural masterpiece answers, and I will see you in the next strategy session.